Assalamu alaikum dears, myself is LK. Here in this section, we'll be just learning the design of a rectangular sedimentation tank. And the sedimentation tank is also known by a settling tank. Actually, there are many types of sedimentation tank, like these are just the classes of sedimentation tank based on location, based on function, and according to shapes. If you see according to location, we have two types of sedimentation tanks, the primary one and the secondary one. Based on function, we have of course intermittent tank and the continuous tank. And according to shape, we have of course the rectangular sedimentation tank, circular sedimentation tank, and the hopper tank. But this is not our approach. That's why I will not go about these guys in detail. Our approach is only the design of a rectangular sedimentation tank. So let's do the design calculation for rectangular sedimentation tank. Of course, I'll do just an example. If you are asked to design a rectangular sedimentation tank for a population of 1 lakh person, the rate of water supply is also known, which is of course 1.5 or liter per number per day. The water will stay for 2 hours in the tank. This is also known by detention period. The data is just enough to design a rectangular sedimentation tank, so I'll just come straight to design solutions. In the design solution, my first approach will be just the capacity of tank. Let me just consider 80% of water supply as sewage flow. So I can calculate the average discharge. The average discharge must be equal to the rate of water supply, which is 150 liter per number per day, times the population, which is of course 1 lakh. If the sewage flow is just 100%, then the multiplication of these two guys is just enough for discharge. But if you see over here, we have considered 80% of water supply as sewage discharge or sewage flow. So I'll put 80% over here. Do some maths with this guy, of course you will get 1 crore and 20 lakh liter per day. Or you can say just 12,000 cubic meter per day. When we have the discharge, of course we can calculate capacity of tank so easily. If you see the discharge is in cubic meter per day, I don't need the day term over here because I just need the capacity of tank in form of volume. So 12,000 cubic meter per day divided by 24 hours, because 1 day is just 24 hours. If you see, the water will stay for 2 hours in the tank, which is just the detention period. So I'll just put 2 hours as a value in this formula. Do some maths. Of course, you'll get 1000 cubic meter is the capacity of the tank. If you see, the capacity of the tank is in form of volume, and the volume of sedimentation tank will be just the length times breadth times the depth, which is of course 1000 cubic meter. So we got a nice calculated value as the volume of the tank, length times breadth times the depth, which is 1000 cubic meter. Or I can shortly say the volume of tank will be L times B times the D, which is 1000 cubic meter. Now nothing is given. The length is unknown, the breadth is unknown, and the depth is unknown as well. So I'll just assume the depth is 3 meter and the length is 3 times of its breadth. This is a nice assumption over here. After designing the tank, we can also review all these assumptions. If they are not good, we can change of course all these guys. Let's put all these assumptions in the volume of tank formula. We'll get of course the volume of tank, length, which is of course 3 times of its breadth. So 3b times b, the b is unknown, times the depth, which is just 3 meter. Also the capacity or the volume of the tank is known. So 1000 cubic meter equals 3b times b times 3. This is just 9b square. Just divide both sides by 9. We'll get of course b square equals 111.111. We don't need b square. We only need the b, which is just of course the breadth of the tank. So just putting square roots on both sides. The b must be equal to 10.5 meter. Now the length is just 3 times of its breadth. I can just put the breadth value in this formula So the L equals 3 times 10.5. We can get, of course, 31.5 meter as the length of the tank. Let me just provide extra 2 meter per inlet and 2 meter per outlet, which is total as 4 meter. So the total length must be just 31.5 meter plus 4 meter equals 35.5 meter. So this is just, of course, the total length of the tank. In the result, we got the length equals 35.5 meter, the breadth equals 10.5 meter, and the depth, which is just the assumption, is 3 meter. But the depth is not enough over here. Let me just provide 1 meter per sludge and 0.5 meter is pre-boat, so the total depth must be just 3 meter plus 1 meter plus 0.5 meter, which is, of course, 4.5 meter. Here is just the detailed result. The length is just, of course, 35.5 meter, the breadth is just 10.5 meter, and the depth is just 4.5 meter. And this is it. Of course, we have done it. The design means just the determination of the size of the tank. And this is done, of course. Thank you guys for watching. See you next time, and wassalam.